Alrighty, welcome back, guys. You didn't go anywhere, I went somewhere. Alright, this is part 2 of lesson 1. Let me see if this light makes it better or worse. I hope better. I think the video quality might be better this way. Hopefully that bar over there doesn't get in our way, but I don't think it should. Part 1 is uploading right now, so hopefully it'll be available by the time you guys are seeing this, and hopefully you guys are seeing this on Wednesday morning. So hopefully you've had a moment to think about this question now, and I'll give you another 10 seconds before I give you a hint. Alright, your hint is that there are 2 possible answers to this question. So it's not always going to be just one. There are 2 possible answers here. So they're not overly complicated. And you guys should have had enough time by now. If you haven't gotten it yet, then I'm going to help you out with this one, and then we will move on from there. So the answer to this one, if you see a second derivative and an original function but with a negative sign, that's probably a telltale sign of a trig function. Not always, but for some of these ones that I'm going to show you guys to start, trig functions. Alright, so sine of x. The first derivative of sine of x, hopefully you guys remember, is cosine of x. Alright, now that doesn't help us because we don't need, we don't want this to be different from that, but it's okay because this is appearing in the first derivative and we don't need to worry about the first derivative in our final answer. So the derivative of sine of x is cosine of x. And then the derivative of cosine of x, you guys had occasionally made a mistake with this. It's back to sine x, but negative this time. Alright? And if you look, we've got y double prime is equal to negative sine of x. But we said sine of x up here is y. Oh, that's a ghastly y. Y, right? And so we just have this negative sign right there. So y double prime is equal to negative y, which is exactly what the question up here is asking for. All right? Now there is a second possible answer, and it's very similar. And hopefully you guys have got it by now. I can almost envision Trey just blurting this out. But cosine of x. Cosine of x derivative is negative sine of x. And the derivative of negative sine of x is negative cosine of x. If you need to figure out why that's the case, just look at the fact that sine of x has a derivative of cosine of x, and then you just carry the negative sign down with it. So what you wind up in this case with is y being cos of x, and then y double prime being negative cos of x, or negative y. Don't know if you can see that there. Now you should be able to see that. So both ways, we've got an answer that satisfies this question up here. Find a function y such that it follows this condition, that the second derivative is equal to the negative of the original function. So hopefully you guys have got that by now, got that copied down by now. If you need to rewatch it again later just to go through the steps one more time, try to go through it at home as well, then you can do that. That's again the good thing about this being on YouTube. Incidentally, just making sure that all is good with part 1. Part 1 is up, so that's good. Alright, forgive my lack of professional video making. Alrighty, so I decided while uploading part 1 that I'm going to leave the whole Greek letters standard form formula of how to get the answer for Thursday's class, because at this point we've got 10 minutes left in what I'm planning on allotting to one video, and this is not something I want to rush. Chances are, because this is the first day with the video lesson, that you guys didn't get a chance to start right away on the 45, so probably cutting it really close for time, even if I make this just 30 minutes across the 2 videos. So what I'm going to do is I'm going to give another example, another 1 or 2 examples of some of these types of differential equations, and then what we can do on Thursday's class is I can show you the formula that you're going to need for just kind of plugging it in and then just going with it. It's not overly complicated. It's not too complicated, really. It's a little bit intimidating to look at, but there's nothing more complicated than usually just a couple of really small integrals. And we've done a couple of integrals, but maybe after one more differential equation here, we'll just do a practice integral or 2, just to shore that up before Thursday's class. So let's see, what's an example that I can give here? Okay, this is a type of differential equation that you'd probably never see in a class. Yeah, okay, how do I want to do this? Okay. This might be a little bit weird. Is this what I'm looking for? Yeah. Yeah, that's what I'm looking for. This is probably going to look quite confusing. Okay. Yeah, okay. So, this is going to look confusing because this is not how most differential equations look, but just to sort of give you a feel for how they work, I'm going to give you guys a chance to guess probably one of the most basic functions that we worked with. It's easier than e to the x. It's a bit more complicated than a line, but it's easier than e to the x. It's easier than those really long polynomials that I showed you a couple times. It's got no big numbers in it. And what I'm going to do is, you can pause now if you like, but I'm going to give you the answer to it, and I'm going to show you how it makes sense. Alright? Hopefully this works, because I don't want to refilm this whole thing. So, let's see how this goes. So, if your guess for y, remember all of these, until you can verify, all of these are guesses. If it's kind of like a mess on like a test paper or whatever, then that shouldn't have you be losing any marks. I'll have a spot left for putting in a guess somewhere on your test. We'll figure it out. But your answer for this one should be y being x squared. Alright? And the reason why, you'll see in a sec, is because the derivative of x squared is 2x, right? Simple enough. Now, if you plug in x squared up in here for y, then you get root of x squared, because that was y, is equal to y prime, which is 2x divided by 2. Alright? Now, if you have a square root of something squared, the square root and the square just cancel. And so what you're left with is just x on this side. Alright? Just x on the left side. And then on the right side, the 2 and the 2 cancel. So what you're actually left with on the right side as well is just x. And so your final answer would not be x equals x. Everybody knows that x is x in any case. what your answer would be is that y must be x squared. This down here, when you finish with x equals x in your final line, this is a check to make sure that this guess is correct. So you'll have a guess that is y equals something, and that something is the answer that we're looking for. And then if you have something down at the bottom where you've sort of plugged in that function and plugged in all the derivatives that you need to up into the original question, then your final answer, if you got it right, should be the same thing on both sides, because that is what's telling you that you've got the right answer. If I had x on this side and x cubed on that side, or x, I don't know, x e to the x on that side, then that would be telling us that no, we've messed up somewhere because these two things are not the same. So that's why it's important to do the check at the end. It's usually not for marks, but we don't have to worry about the marks right now. This is just a check to make sure that you've got the right answer. If the check is what's stressing you out, then go with your guess, and if it makes sense in your head, go with that. Again, it's a little bit tough to sort of just look at the question and figure it out, especially when it's got all these fancy things going on with like a square root sign and a fraction, and it can be a little bit intimidating and it can take a little bit of getting used to, but I think that you guys are going to get the hang of this pretty quickly. I found differential equations easier than integration by parts when I started out with both of them, even though differential equations was taught to me in my second year and integration by parts was in my first year. So don't stress out, don't overthink it. Have a look at the question, see if you can figure things out. Just by looking at it, it can be a little tough, I know. I will give you guys that formula in our next class. And what I want you guys to do right now is, if you have any time left in this class, maybe you magically got started a little bit early, or these videos are a bit under 15 minutes, so it should be a little bit less than 30 before you guys finish. What I want you guys to do is take a couple of minutes now, if you have the time, and write down 2 things that you think went well with the filming. 2 things, I mean, if there were 2 things that went well with the filming, and 2 or 3 things that you think I should improve on for the videos, something that you think I could do to make it better. Maybe the lighting was bad, maybe something like that was bad, maybe the audio was off. Let me know in an email or through Miss Fiona, and I'll try to fix it for next time. I'm probably going to film the Thursday lesson right now as well, so I might not make these changes until Monday. But yeah, let me know. And if you have any questions about the differential equations, of course, send me an email or through Miss Fiona or something. All right? So that's the end of our first video math class. Again, hope you guys had a good weekend. Study hard, stay on top of your work, and I will see you guys tomorrow. Have a good one.